in something and my tab is broken here. That's unfortunate. Thankfully, we're in Tmux, so we can just make a new tab. And I'll just kill this one. It's dead. Boom. Problem solved. You know, things happen. You gotta be ready. So now I'm gonna have to clean out all this. Oh, what a mess. Oh, I don't. Okay, great. Let's open back digits. Digits data dot py. Yeah. Okay. Now we're working again. Sorry about that. Always a little bit of nonsense. We had created data previously. Let me show you what that looked like, since you may have forgotten. I may have forgotten. It's been a week and a half. 2 weeks, I guess, proper. Load up some TensorFlow. We got the TensorFlow working. That's all. Everything's all hunky-dory. I made data. What did I do? I mashed together 2 images. That's this line here. Combined them, ran the whole thing, saved the data right here, and then we're going to load it up. I'm going to do that in a new file. So import numpy as np, and I'll say data equals numpy.load. I think it's numpy load or load z. No, just load. Okay. And that is on a file or loads stuff that you saved with numpy.save. Cool. What did I save it in? Digital data.npz. Let's go grab that real quick, and then we'll remember what we're doing. Just trying to build a model. Trying to build a model that will determine what our digits are in this data. So this is, oh, fracking darker. Do I have to read this? What nonsense is this? Things I don't remember about load, you know? I don't use it every day. Loads arrays are pickable objects from whatever, blah, 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 blah. What does it return? Array, tuple, dict, etc. If it's stored in NPC, the return instance must be closed to avoid leaking file descriptors. Wait, do I need to like provide the? No. Okay, data close, I guess. Now it's data. What is this? One of these things. I think it's labeled with this. Oh. Great. That's real cute. Real cute NumPy. Things I like about Python 3, but then there's things that really grind my gears. Okay, I have 4 arrays apparently in this data set. Why my life had to be this complicated, I don't know. Okay, what are those 4 arrays? Well, we could just go look, right? Like, what did I actually do? Oh, it's this training, it's the verification, it's the labels, Okay. I was debating just trying to figure it out. Why don't we come over here, use the same variable name, make our life good. There we go. Equals, put this on a new line just to keep it a little bit clean. Array 0. You could have given them names, but I chose not to. Because I don't know, a terrible person. Why? No. You know what I should do? Do this. Oh. This makes way more sense than trying to put it all in one line. That was a terrible idea. There. Now I don't need this. B, that's still T, labels, and labels, and V. Cool. Except these don't all want to be 1. There we go. 1, 2, 3. Data is now about to be read in. Come on. Killing me, Smalls. You're killing me. Read it back in. There we go. And then data.close, I guess. That is not how I remember that working, but that's okay. That's our data. What does it look like? It looks like this. Got 2 to the 16, 28 by 28 images. So if we take a look at one of them, plot that p color mesh of, I don't know, take a look at, let's not do 0, let's do the last one. You tell me, what 2 digits does this look like? I'm like twisting my head around here. This is a hard problem. Like maybe a 3 is in there? Is a 2 in there? Is there some, what is this? Like that's absolutely goofy. Yeah. Alright, let's kill that. If we wanted to see, well, what labels are there? Take a look at the labels. No, I don't want to, no. But don't plot the labels, because the labels are just integers. Just look at them. Oh, there's a 1 and a 9, 8, 7 in there. Almost. There we go. I'm not sure where this 7 is coming from. Does someone do a 1 like this maybe? And then a 7, is it a 7 upside down? It's very strange. Are these upside down actually? No, I don't even know. You know what? I think this is actually upside down. Because I bet what I want is matrix show. Yes, that makes way more sense. Well, it turns out as a human being, I have not fully generalized what's going on. Now it's clearly, there's a 7. Also, it's nice and square. Makes things a little easier to understand. Just data augmentation, right? And this clearly is the 1 part. So you can even see it here. Okay, that makes a lot more sense. That's the kind of data we're working with. We want to, in the end, get something that looks like this, you know. It says, oh yeah, it has a 1 and a 7. That is what we want to end up with. So it's a variation on MNIST. And I think it's going to be pretty cool. It's going to be really hard, which is good because MNIST is not hard enough. Yes, let's get that I on. But now we got our data loaded. Previously, I was about to say last week, but it was 2 weeks ago, we had put together this dopey model over here. That's really just, all it is a simple linear regression to slap out these 10 numbers. Each one is like a little binary classification problem because we're going to be labeling multiple things. Is this value 0, 1? Is this 0, 1? Is this 0, 1? So on and so forth. So that's what we're computing here. I don't recall how this worked. To find out how long did it take, really? Let's find out. I've imported TensorFlow. I think I have. TensorFlow STF. And we're just going to let this... Oh, but there's some other... We grab those other lines. We grab this stuff too. I've already run it, but I should have it here. There we go. Get rid of that. Move this down here. Perfect. All right, I think that's good time. Let us now run this. Again, absolutely dopey. Linear regression model. It's going to yell at me for a bit. Oh, okay, good. I actually can train it for however long. That's terrifying. Validation accuracy 0.74. Wow. That is very surprising that it's even that good. Is the accuracy working correctly? That is an important question I have. Because you're creating this multidimensional output. I'm not 100% sure it's working correctly. That's wild. That is absolutely wild. That you can get that high on this data set. I guess you have multiple pieces of information. Let's take a look at what some of those predictions look like, shall we? Model.predict. And let's put in our validation images. .reshape. Right? Yeah. -1, 784, which is 28 times 28. How do I know that? Because I've worked with MNIST enough. Okay. Those are our predictions. Those are who's a what in the sauce? Right. Well, those are not correct at all. Right? These are supposed to be values between 0 and 1, every single one. They are clearly not. Right. So what went wrong? Well, there's no activation on this that says, oh, by the way, activation. Let's put in this line. Activation equals a sigmoid, right? I think that's right for this. I think that's correct. I'll double check that later. So let's make a new model, you know. I don't know how it got to 75% accuracy, whatever other nonsense. That's a bunch of nonsense. Oh, look! Oh, what do you know? It actually trains a whole lot better. Amazing, amazing. What do we get now? Yeah, now these are numbers like, oh, that's a 1. That's clearly a... Well, that's a 1. It's 0.99, whatever. Curiously, it believes, you know, there's 3 things here, which is absolutely not the case. Right? I take a look at pred 0. Well, it says there's 4 things. That's kind of funny. Whereas, if you take a look at the actual labels, did I get the correct one? I want 0 and 4. 0, I got, but I also declared that there's, you know, a 5 and an 8 and a 9 in here. So there's a problem in this model, in that it's allowed to tag as many things as it wants. I happen to know only 2. There must always be at most 2 things. A couple ways we can handle this. We might just say this is fine and not worry about it. We might futz around with that later. And of course, this is a model that has been trained, you know, hardly at all. So in fact, let's let it think about what it's done for a bit here. Okay, we'll come back to this. We'll say dopey ML model right here. You know, just a pure regression on the problem, on all those things. Is that like maxed out already? The loss? No, the loss is going. No, the loss has gotten worse. Whatever. I'm gonna let it go. But I want to propose not exactly that first. We'll come back, we'll make like a convolutional neural network or whatever, who knows, who cares. But let's just look at averages. Averages of MNIST data. That's what I want to look at here. So let's come back here. I want to grab my MNIST data. Right? Yeah, here we go. Boom. How did I make my validation data? Did I make it from the MNIST validation data? I think I did. Right? I did, yes. Okay. So, I'm gonna grab that data set again. I got this training. Son of a gun. Yeah, MNIST.load. Yeah, what is going on here? Ugh. Oh, what a headache. Okay. Let's just say it's mtrain images is train. Train 0, mtrain labels is train 1, right? Perfect. So what we're going to do is compute some averages for each character, for each digit, so to speak. We had done something like this. If you want to look at, well, I want to say, what are all the zeros? I can do this. Empty MNIST train images. These are all the zeros, right? And if you sum over those, sum over the first axis, right? Doink. Now you get a 28 by 28 thing. Except I don't want to take the sum. I'm going to take like the mean. There we go. And if we, I don't know, plot that. Mate show. Yeah, matrix show. I always want to do that. I mean, the MNIST doesn't care. The machine learning model's not going to care, but I do. This is our average 0. You know, it's kind of blurry, which isn't too surprising because people put zeros in slightly different positions. But it's, what is going on? It's really funny when I move my mouse over things. It gets all goofy. Anyway, that's the average 0. Let me include that over here. Cool. I want to make the averages for all of them. Let me make an array just called m for the mean. We'll initialize it with some zeros. This is going to be 10 long, comma 28, comma 28. Yeah, and it could be float 64, whatever, I don't really care. And I will say for I in range 10, for all our digits, that is, we're going to do this. Grab this mean, down here, and I'm going to say m of that thing is equal to this. Except not 0, I. Now we'll have all those. And now I didn't do auto indent. Almost got burned. Would not have been a good time. But instead, let us do plot.pcolormesh. No, macho. Oh, I don't have a good way to show all these at once. Let me look that up real quick. Chromium browser is the browser I use. See if this ever loads. The risk of looking things up live. Okay, we are looking up. Right, I wanted to look up subplot. Matplotlib. There's an easy way to make subplots, I remember. Subplot. Gallery subplots, plural. I think that's the one I want. Create a figure and set of subplots, and rows and cols. Okay. I believe that's what we want. Let's do that. And this is plot.subplots. So I'll say something like big equals. In rows is going to be 4 rows, 3 columns, because I want to plot all 10. Share X, share Y, whatever, that's not really important. Create a figure and a set of subplots. Right. And here, which axes are we going to plot on? Okay, perfect. So we'll do that. And then, actually what I should, no, we'll do this. We'll make the figure appear when we create our data, or before we create the data. And then I'll say, what? I gotta get the axes, right? Oh, it gives you axes as well. That's interesting. Creates figure number 10 with a single subplot. 4 polar axes, axis 1, axis 2. Unpacks the output array immediately. I don't think I want that. I think I want fig, comma axes. And so I will say X, I got 3 by 3 here? Yeah, 3 by 3 plus 1 on the bottom. So not I mod 3. Duh. I divided by 3. So that's going to be 0, 1, 2, or 3. And Y is equal to I mod 3. And that should give me a nice unique position. I should be able to say axes of X comma Y is equal to, and then do my plot, right? Or not equals, but dot make show M of I. Let's see how that goes here. Alright, that actually worked reasonably well. I mean, we got 2 extra spots, but I don't really care. That's fine. These get bigger? A little bit. So yeah, you got a 0, you got a 1, especially funky up at the top and bottom. A 2, a couple different ways to do that. A 3, a 4, a 5, a 6. That's a pretty nice 6. 7, I'm surprised there's not more cross, like the European style there. 8 and 9, you can tell people can't decide whether to go straight down or whether to go diagonal. But the 6 doesn't seem to have that problem, which is interesting. Also interesting on the 4, most people do like square 4, not the triangular 4. That seems to be what's favored here anyway. I find that interesting. I want to use these to like build up a sort of non-machine learning version of the same model. Of, can I just use these basic averages to slap together and say like, well, how much does this look like a 0? How much does this look like a 1, 2, 3, 4, 5, 6, whatever, each one. And just use that. So we sort of want to filter and say like, how close are they? Because M of I, yeah. Actually, what is number max? Yeah, these are all still the same data types, U and 8s, which is all hunky-dory. Whereas if I take a look at my training data, it's only up to 127. That's surprising. How did that happen? Oh, is it signed? No. That's really strange. I didn't realize that. Huh. Why would I have done that? It's somewhere I divide by 2 and I didn't need to? Did I take a mean and then divide by 2? When in fact, I did not need to do that. Where's the mean? Or do I just literally add them together? NumPy random choice. Give me 2. Replace equals 2. What? Hang on. What kind of data set is this? Yeah, replace is true. Let me fix this now. That's fine. That's totally fine. This is all fine. I mean, you could get the same thing twice, but actually, that's terrible. Whatever, that's fine. These are all my indices. It's a single run. What happened here? And again, I do apologize for discovering terrible things going on here. This is which things we're doing. This is just creating the big list of things. Labels, images. Oh, combine images. Right, that's under function. Over here, combine images. I grab the mean. That's weird. Why would it give me 128? Oh, is the original? Hang on a second. Is the original that way? MNIST. Images. No. I should have had a max of like 255, because there really ought to be places where it's 255 and 255 add together. Or at least something bigger than 127. This is suspicious to me. I mean, it's my show. I'm going to investigate this right now. Because otherwise, there's something wrong with my data, and that's what the whole show is about. So put this model on hold, and we'll investigate what went wrong with my data. Maybe I can just multiply everything, or divide everything by 2, and that's fine. Maybe I can multiply all these numbers by 2. Is this the same way? Probably is. Yeah. What is going on? Okay. Let's try to fix our data. Uint 8s, Uint 8s, that's all good. Maximum value in a Uint 8 should be. And just double check that. NumPy.zeros of, I don't really care. 5, dtype equals NumPy.uint 8. 1 byte per. Yeah, that's all. Dang it. There we go. A of everything equals 255. Yeah, it's all hunky-dory there. What went wrong? I don't divide by 2 anywhere. Do I divide by 2 when I'm saving it here? No. Is it the way I saved it? Did I load it funky? I mean, not any funkier than I had to. This is truly bizarre. I am surprised. Rather surprised here. What is going on here? Try equals this. What about that mean of all these indices? What if I take my original data, it's called IM, right, of the first, I don't know, 2, just to get something here. And I need to run this numpy.mean operation on this. Oh, that's going to take the mean over everything. Right. dtype equals numpy.uint 8. Axis equals 0. Yeah, it seems to be maxing at 127, which is awful strange. Somewhere it's like pre-dividing by 2 or something. Or something worse. This is like, it's like a bug in numpy.mean or something. Yeah. That's really strange. But if I do this myself... Oh, I know what happened. I know what happened. This looks real weird. Okay. These things are each numpy uint8s, right? So when you add them together, it will happily carry the addition and keep it in a numpy uint8, which is bad because when I add 255 to 255, I end up with, what, 254? I end up with not enough. That's like -1 and -1, yeah, 254. Which is, you know, fine. But then we divide by 2, which is 127. That is what's happening. We just need a larger data type when we do this. All right, so there is, the data is mangled. We've lost some resolution here. You could just multiply by 2 and pretend everything's fine, but it's not. What we're gonna do here. I could do all the data. Yeah, let's just do that. We'll come back here. When we do this, tx16, we're gonna use uint 16s instead. So we'll say, make a new array, tx dtype equals numpy.uint16. Glad we got this. So data types, easy way to get burned. Easy way to get burned. Let's do the same for our validation. Perfect. Okay, now I gotta run all this code again. Oh, bother. What other stuff do I have here? Do I already have train? I think I have it. Is the thing. Okay, good. Let's grab that. Okay, I don't think I need that. I don't need new images. I don't need new label. I just need to call this function. I need my special bad time exception to break out of a loop. And then this whole function. There it goes. Good. Doing that much, like, copy paste over used to crash my terminal. I'm glad that doesn't happen anymore. All right, let's make the uint16 versions. This will consume twice as much memory. If I didn't want that problem, I could have created it over here. And I probably didn't need to do this for the validation set, but whatever, we did. We're doing it. Takes a little bit of time. Oh, that's right, I implemented a progress bar. That's cool. I'm glad I did that. Okay, but now you'll note that this is still uint8. That's surprising. I thought it would have been uint16 then. Something wrong happened. Oh, I didn't put in the right kind of data. Duh. That was dumb. You know, make sure you use your real data when you run that. Unhashable type. Cute. Real cute there. Real cute. What is TX type? Oh, is type TX a... No, that's not right. This is odd. Type TY. Those are both arrays. Type of TY is 16. Lies. That's all I'm hearing. Unhashable type. Oh, bother. What is it complaining about now? It's doing this and it says, no, that's still an array. I can't do that, mate. Why was this not a problem before? You know, one of those things. One of those things. Oh, because I put in the wrong kind. Duh. Usual problems. Make the correct data. Use the correct data. Observe when there's an error that something has gone wrong. Give yourself a progress bar. Good times. Alright, but fixing our data, very important step. Maybe it'll be a little bit easier now to understand what the heck has gone wrong. Alright, made all our data again. Reload. Oh, now this is, oh, you know what I did though? Now this, oh, it's still uint 8. Nope, something's still wrong. Okay, what went wrong here? Let's just do this stuff. BX16 is this. That's uint 16. Is there uint 8 over here? There is. There is. Oh, I could have just done it here. Duh. Silly me. Silly me, I recreated there. Alright, so I'll tell you what, we're just going to nuke these. Because we're doing it inside the function. So we take care of that ourselves. What we're going to do, let's come over here. Array. There, that should be better then. So we'll end up with a uint 8 at the end. Things, you know, I'm sure several people saw that, and I did not. The nature of looking at one's own code. You will never see these things. You look at it and say, oh yeah, I know how that works. I got that. This really shouldn't even take this long to do the 16 things, also. That's... But like, it just doesn't take long enough for me to really care that much. Right? It's like, it's a few seconds that I have to put up with. Rarely, right? Okay, let's see, what we got? 127 still. Things are still screwed up. Why is that? Like, now I want to know where all the uint 8s in my code. Like, now I'm paranoid. Yep, look at this. Yep, that needs to be 16. Thought I could get away with that. I could not. Labels are fine. Okay. Let's rerun that. One of these days, the data will be nice. One day, the data will be nice. But today is not that day. Okay. Again, let's just run the validation. That gets added into there. Nope, it's screwed up. I apparently lost something here. What is going on here? There we go. That just got a little bit mangled. It's okay. Still got it. Still got it. Much better. What about you? It's correct D-type. It's not the correct D-type. I gotta fix that. But it's got the correct maximum. This was supposed to be an 8. There we go. One more time. How many times can I make the same data set? But correctly now. Alright, what's the max now? Boom, look at that. Let's make our actual data. What's the max now? Boom, okay, much better. Let's save this. Yeah, this will be a lot easier. You know, twice as easy now that we're doing that. Okay. Reload. Let's make sure everything's hunky-dory. I'll leave them do all this nonsense again just for giggles. Yeah, does it actually really change? No, because that's nonsense anyway. And I don't trust this accuracy metric at all. Oh, you know why this is so good? Because most of them are zeros. And so if you just always predict 0, you will have an 80% accuracy. So really, it's like 50% is our accuracy. Right, so we need to make a new metric of the number of ones that there are, which ones are correct. So maybe that'll be a thing we work on in a future episode. Yeah. Take a look at this. Yeah. That says 0 and some other stuff and some other stuff. Oh, the data's different now though, right? Because what is not VM, VLab 0. Haha, none of those things. Yeah. Wrong. Wrong. Oh, that's a 0. That's right. Ah, that was correct. Okay, we got one of them. That's like 50% accuracy in this situation. That could have been so much worse. What does it actually look like, though? The first one. This is a 7 and a 5? What is this thing, though? I don't know, man. I'm sorry, what was this supposed to be? 9, 8, 7, 6, 5. Boom, human being did it. Look at that. Machine learning model, only 50% correct. Anyway, where was I? I was making this stuff. There we go. I didn't need to make the zeros again. There, now we have our averages. Those are all still the same. Yeah, those are the same values. Those didn't change. Those were always correct. But I wanted to try to see, can I just map one of these to, like, whatever our training thing is, right? There's this, and there's, like, well, what is this one? Oh, that's the one that's 5 and a 7, right? So, well, what does it look like when you subtract the m of the 5? Right? Well, you know, that looks kind of like 0. What happens if we average, like, the ones we actually want? I can't just take the mean because it's all UN. Oh, I should just store everything in 16s. I really should. Oh, but that's a float, so it'll be fine. Okay. M5 over 2 minus M7 over 2. Like, what does this look like? How close is this? Those being the correct things. Oh boy, what happened here? Why does it look like there's a 4 in here now? Oh, this is a training set. This is a totally different set of labels. Which has a 2 and a 4. Okay. Come back up here. We'll subtract those 2 from it. Try to see how closely this looks. And the answer is, not very. Not very. What does this actually look like? I mean, is this one that we're going to have any chance on? Well, that's pretty clearly a 2 and a 4. Yeah, it's me. Pretty clear there. I feel like that should be a solvable problem. What I want to do, though, is enforce an order here. Most of these are about 0. Oh, how big is this? How big is 163? The min is negative 55, the max equals 255. Yeah, okay. So I enforced a minimum and maximum on the color scheme here. So you can see, like, oh, this is 163, this is pretty bad. You know, it's not the best. Not the best for sure. But this is something. This is better than nothing. If you subtract different things, it's going to look real bad. So what I want the dumb model to do, let me think about this. I don't want to try, well, we could actually try all pairs of numbers, and I happen to know there's 2, right? Subtract them all and see how that goes. So for each training image, I'm going to create a new array. I'm going to create 10 choose 2 arrays, right? Where I'll really just make like 10 by 10, because whatever. What's 100 things? It's not a big deal, right? And it'll always be like IJ with JI. So, let me just call this A for now. None but add zeros. I want this to be 10 by 10 by 28 by 28? No, just 10 by 10 actually. Because I want to like take the sum over all positions here. Like here I wanted to visualize what the whole thing was. But in reality I want to take the sum over that. So this is for a given thing. How much data do I have? And data equals length of t image, right? Yeah, there we go. Okay, cool. Do that first. I want that many of these. And I want this to be float 32. Save a little bit of space here, because I don't think float 16 is a thing, and definitely not a float 6. Oh, there is. Huh. Yeah, sure, let's do 16-bit floats, whatever. Okay. We're not getting too wild here. No, I like 32. Memory is not a problem. 32 keeps me relatively safe. So what I want to do is for each data point, say for the ith row and the jth column, subtract those two means from the actual data point. So let me, actually, for I in range 10, for j in range 10. Probably the easiest way to do this in a vectorized fashion is to say that a of everything, comma I, comma j, is equal to a of, no, not a, the training images, right? All the training images, minus we'll broadcast the M and the J, and we will make sure to do this operation first, right? And then I just want the sum of that. And I want this number to be small to indicate that, yes, this was made up of, in fact, this value in this value. So that's all I want that to be. So A is like our filtered whatever data. All right, let's see how that works. Doing 100 things shouldn't really take that long. I'm losing my mind here. Did I lose A? I lost. I didn't. No, I had enough. Should not take that long. Why are you taking so long? Yeah, real cute there. Oh, bother. Like doing 100 subs, it's not that much. Right? Like, what's going on here? Really? Oh, jeez, oh man, this is terrible. This is taking multiple seconds. There's probably a better way to do this. So maybe I do want to only do this, right? And then say A of, oh yeah, that's at least a little smart. A of everything, comma, I, comma, J. At least don't have to compute it twice. So now we have this thing, right? So for every image, I have subtracted out every possible combination of things. Let's do some subplots so we can actually take a look at this. Now that I've got my subplot, I don't have my subplot code in here. That was foolish of me. Oh no. It's fig. Oh no, I do. Never mind. It's right there. It's right there the whole time. Didn't need to freak out about it. And in fact, I should just do that right here, shouldn't I? I should. Let's let's create the figure right here, and this will be 10 by 10. Except I have this for every single. Right. I just want to look at like a particular image. So let's do that. Grab these. What I want is axes of I, comma j, not dot equals, dot mat show of A of, let's look at the first one. Just because, to look at something. IDX, comma I, comma j. And also, j, comma I. Those are the same, so we don't need to fuss around with anything. Alright. We got A. It's got numbers in it. Some of these numbers are rather large, actually. That's not right. That's not right at all. The scale of these numbers should not be this big. Not E plus whatever. That's something screwed up again. Oh, this is U and 8 again. Whereas, M.dtype is float 64. Wow. Why did I do that to myself? Why would I do that to myself, you know? Float everything. What if I just did this? Like, that shouldn't take that long. And what's the D type of this? Float 64. Oh, and then it's gotta like coerce all the types together. It's a mess. Let's do that. Right, yeah, I didn't really need to do that. Okay, do this. Should be a little bit quicker. There you go. Yeah, each gets quicker and quicker, each sub index there. Why are these so enormous? What? What is going on? This makes no sense. Hang on. First of all, what? What? This isn't right. I wanted to see a nice, not identity, but whatever it is going along the angle here. There's something wrong here. I mean, that's correct, right? What went wrong? Oh, not in range. Oh my gosh. Hi. Y in range J, that's just so wrong. Right, because it'll start with the 10 minus I guess. Yeah. One of these days, you know. One of these days, the data will be right. These numbers still don't look right to me. I don't know what the heck's going on. At least it's right D-type now. That's cute. Why is there nothing there? Why is it? Oh, because that's still open? Garbage. What? This makes no sense. Right? Like, well, clearly this is something right. You know, one. Whatever's in here. Or that's like way too big. Maybe that's the opposite of what I want. Okay, so there's some logical error in what's going on here. We need to fix whatever that logical error is and when we're creating this A. We're getting a bunch of zeros, a bunch of end data. Okay, let's just do one at a time. Look at the first one, you know? Just save that off to a separate variable, just so we got it. This is what it looks like. Take a look at that. TT, right, I said? Right, this is the 2 and the 4 together. The 4 and the 2. Very nice 2 there that someone created. Great. Now, what is this supposed to look like? Well, this is supposed to look like, say, an M of 2 minus an, oh, hang on. No, that should be fine, hang on. M of 2 minus like an M of 4, right? Should zero out most of this other stuff. Yeah, you got some places that are kind of still big, but not super big. Some places that are really negative, you know, that's how it happens. It happens. But I should be able to just do the sum of this. And that is huge. What? Oh, because I am just taking the sum over, you know, a large number. This is for a single image. It happens to be this value, right? It's not really what we want. Because this is this number, right, divided by 784, it is our average, how much we're off. But I've got 784 times 2 to the 16, right? And that's how many we're summing over. So you're doing this number, and it's like it's times 2 to the 16. Which is a little bit bigger. I feel like a 32-bit float should still be able to handle this without any problem. But that's fine, because we'll just take a mean instead. See how that goes. It's probably still a large number of errors, but we'll roll with it. All right, this part I'm pretty sure is correct. These numbers are all vaguely in the right ballpark now. We still got all these zeros, right? Let's see if we sort that out today or not. Yeah, this is, you know, semi-problematic. Like, what happens when I is 9 and J is... It's like, I can't... Oh, man. This is so weird. Alright, there's obviously some incorrect thing in how I'm arranging this. So what we're going to do is I'm going to comment out that line. We're just going to do the full thing. It's going to be a little slow. That's okay. We're just going to do that to see if that gives us what we expect. And if it doesn't, then I complain. I say, no, I did all 100. Come on, man. Okay, that's what I expect to see, right? So why wasn't that happening? I think perhaps what I need is between I and 10. I think perhaps that's what I'm missing. Let's try this one more time. Only got a few minutes left here, so I think we'll try to get this going and then we'll call it a night. Is what it is. Okay, that's got numbers in all the places, so I like that. Yes, that looks correct. Okay, I was just doing this. Dumb. Wasn't a problem. I and 10. I ought to know better. Okay. So, for the first one, let's plot these axes. See what that looks like. Not enough values to unpack. Expected 2 got 0. Well, meh. Oh. Hang on. That's A of... What is A? What is the shape of A again? All my things, right? Right, these are just numbers. These are just 10 by 10 values. So I don't need this nonsense. Right, if you wanted to look at this before taking the mean, then you'd have to do something particular. But I'm not doing that. I just said, nah, screw it, give me the mean. I just want to know over that range. Okay. Well, then what we really want... Yeah, I need like 2 to the 16 of these things. Let me just delete this nonsense. We can just do plot.makeShow of... Let's take a mean over that. Over all data points, right? Like, how bad is it? That's no. A of 1, A of 0. Those are all the same, aren't they? Right. 'Cause I just took a mean over everything. Right, I didn't really want to take a mean over that, over everything. I wanted to take a mean over axis not 0. Axis 1, I guess? And then axis 1 again? Axis to axis long which means are computed. Oh, you can do multiple. Okay, perfect. 1, 2. Okay, I think that's correct. Let's find out. Tuple indices, yeah, okay. Yeah, what is I and J, this situation here? Can I do that? Integers or slices, not list. What? But you said I could take a multiple axes, right? Axis or axes, the default. If this is a tuple. Oh, it has to be a freaking tuple? No. Oh my god. That's the thing that ticks me off. Like, it has to be a tuple. It cannot be a list. Why? That doesn't... Not doing anyone any favors. Oh yeah, now it's fine. Look at that. Okay. Now this makes a little bit more sense. A dash shape, A of 0, or A of 0 rather, A of 1. Now there's different numbers. Hey, great. Doesn't really make sense to take the mean over all of them, right? That is still really strange. Why is that the way that is? What? A of 0, A of 1, A of 2, A of 0 minus A of 1. That's curious. Why are they always the same value? I should not be surprised by this, I suspect. Because I'm taking whatever the initial values are. Hang on. Oh boy. The initial value for that particular object. This is just the mean difference between the first one and the second one. I mean, showing it every single position, but... Show me the first one, yeah. Show me the second one. The same thing. Well, that's curious. So there might still be some problems here. These should not all look... 5, 7.7. They're just scaled differently. Negative 57, negative 50.7, 24.5, 24.8. This is weird. I don't like this. TIM.shape. Yeah. So there might still be a problem here. And we might just suck it up and make the machine learning model and say like, this is kind of hard. This is one reason people make these kind of models, you know, to futz around your data in quite the same way, but it's helpful to understand what the heck is going on in your data set. All I wanted to make was the set of the object, you know, minus M0, minus M, but yeah, minus M0 again. That's true. That's something I actually don't want to do. What is this value? That's that magic number. This is some different magic number. Different number. Different number. Like, these are all different numbers. Hang on. The big yellow duck. No, I don't remember. I had a nice thing for scanning through a whole bunch of heat maps, but doomed to know what happened to it. I'll have to install that in another time. Okay, so that is what it is. We may fuss with this more next week. We may just say, we're not going to worry about it too much. But we did some cool plotting to show off, you know, what these averages are. We want to try to use them to understand what's going on. We might still use them to make intermediate features. Just, you know, like the thing minus a particular average as opposed to minus all pairs of averages. And then use that to try to build some kind of expert system. I still want to come back to this a little bit. But then we can take a look at, you know, at our predictions some more. Like, why are these predictions so terrible? I don't know. Well, that only has 2, you know? See? Only 2 answers. And I bet... it's, you know, we got one of them right. The other one, not so much. Alright, that is all I have for tonight. So make sure you stay safe in the data mines, and I'll see you next week. Take it easy.